Hello my precious friends, I really hope that you're doing great. Welcome to our today's class. It's our 6th lesson on a given Form 2 mathematics topic called equations of a straight line. So we are looking at our 4th example, which is a past Kcse question tested in 2018, paper 1 question number 18. It reads that two vertices of a triangle ABC are A has the coordinates of 3, 6 and B has the coordinates of 7, 12. So part of the question, we are required to find the equation of the line AB. So let me start by sketching this particular line AB. So if this is our line AB, of course, we are given the point A, whose coordinates are, we have 3, then 6. Then you also have another point B, whose coordinates are, so point B, we are given the coordinates of 7, then of course, 12. So we are told to find the equation of the line AB. To find the equation, we need to have the gradient and at least 1 point on that particular line. So we'll start by getting the gradient. So the gradient of the line AB, of course, will be given by, we take y2 minus y1, then we divide by x2 minus x1, or simply what we call the change in y divided by the change in x. So if I let this to be x1, then this to be y1, of course this will be x2, then this will be y2. So if I substitute, the gradient will be given by my y2 is positive 12 minus y1 is 6, then divided by my x2 is positive 7, then minus x1 is positive 3. So this will give me 12 minus 6, I'll get positive 6. Then divided by 7 minus 3, I'll get positive 4. Now, if I divide through by 2, so by 2, it will go here 3 times, by 2, 2 times. So it means that the gradient of the line AB will be given by 3/2. Now, having found the gradient, we can easily get the equation. So having the gradient, and of course I'm going to pick one of the points. So let me pick the point A. So I'll use the point A, which is 3, then of course 6. Then I'll also pick a general point xy, so that I can use these two to find the equation of this particular straight line. So I'll let this to be my x1, then this to be y1, of course this to be x2, then this to be y2. Therefore, the gradient is given by change in y over change in x. We already have the gradient, which is 3/2. So this must be equal to y2, then of course minus y1, then divided by x2, then minus x1. So that means 3/2 will be equal to my y2 is y, then minus my x, that is my y1 is positive 6, then divided by x2 is x, then minus x1 is positive 3. Now when I do a cross multiplication, this one will multiply with 3, then of course 2 will multiply with that. So we are going to end up with 3 into brackets x minus 3 being equal to positive 2 into bracket y minus 6. If I open brackets, I'm going to have 3x, then minus 3 by 3, I'll get positive 9, being equal to 2y, then minus 2 by 6, I'll get 12. So I'll take 12 towards the left hand side, so that I'm going to have 3x, then minus 9, minus 9. The 12 will become a positive when it crosses the equal sign, is equals to 2y. So this will be 3x negative 9 plus 12. I'm going to get a positive 3 being equal to 2y. Now, if I decide to express the equation in the general form of the equation of a straight line, which is y is equals mx plus c, I'm gonna get the following. So this equation can be rewritten as, I can decide to start with 2y, then is equals to 3x, then of course plus 3. Then I'll divide through by 2, divide through by 2, divide through by 2. The 2 and 2 will cancel out, so the equation will be y is equals to 3/2x, then of course plus 3/2. Therefore, this is the equation for the line AB, which is expressed in the general form, which is y is equals to, of course, mx plus c. But even if you left your answer at this particular point, you will still score full marks because the question did not specify the format in which they want the question to be in. But if the question was to leave your answer in the general form, which is y is equals mx plus c, then you must leave your answer in this particular format. Y is equals 3 over 2x, then plus 3 over 2. Then we'll move to part B of the question, whereby you are being told that find the equation of the perpendicular bisector of the line AB. Now I'm going to sketch the line AB. So if this is my line AB, of course, point A, we were already given the coordinates of point A. The coordinates were 3, 6. So A had the coordinates of 3, then 6. Then point B, we were also given the coordinates for point B. Coordinates for point B were, that is 7, 12. So this is 7, then of course, 12. Now, when you are told to find the equation of the perpendicular bisector, remember a perpendicular bisector will subdivide the line AB into 2 equal parts, such that this angle is 90 and this distance will always be equal to this other distance. Therefore, the point of intersection of the perpendicular bisector with the line AB will be the midpoint of the line AB. So this is what we are calling the midpoint. So the coordinates of the midpoint will be the point through which this particular perpendicular bisector is passing through. So this is what we are calling the perpendicular. This is the perpendicular bisector. Perpendicular bisector to the line AB. So to find the equation, we need 1 point and the gradient. So I'll start by finding 1 point. Of course, the point will be at the midpoint. So the midpoint, will get the midpoint of the line AB. Of course, the formula for finding the midpoint is usually you take x1, then you add x2 over 2, then a comma, you also take y1, then plus y2 over 2. You just find the midpoint of the coordinates along the x-axis and also the y-axis. So I'll let this to be my x1, then this to be y1. Of course, this will be x2, then this will be y2. Therefore, the midpoint will be given by my x1 is positive 3, then plus x2 is positive 7, then divided by 2, then comma, my y1 is positive 6, then plus my y2 is positive 12, then of course divided by 2. So this is going to give me 3 plus 7, I'll get positive 10, then divided by 2, comma, 6 plus 12, I'll get positive 18, then divided by 2. So this is going to give me 10 divided by 2, I'll get positive 5, comma, 18 divided by 2, I'll get positive 9. Therefore, it means that the coordinates of the midpoint is actually 5, then comma, 9. Now, the other thing we need to find is the gradient of this particular perpendicular bisector. Remember, we had already found the gradient for the line AB. So if the gradient for AB, if we let that gradient to be M1, the gradient for line AB was 3 over 2. So our M1 is 3 over 2. So we need to find the gradient of this particular line, which is our M2. Now we know that for any given pair of perpendicular lines, the product of their gradients should give you -1. Therefore, M1 multiplied by M2 should give you -1. Our M1 is 3 over 2. So this will be 3 over 2 multiplied by M2. It should give us -1. So to find M2, I'll multiply through with the reciprocal, which is 2 over 3. I also multiply this other side with 2 over 3, so that 2 and 2 can cancel out, then 3 and 3 can also cancel out. So I'm going to end up with the following. So it means that the gradient for this particular line M2, which is the perpendicular bisector, will be given by, so this will be -2 over 3. That is -1 by 2. You'll get -2, then the whole thing divided by 3. So this is the gradient for the perpendicular bisector, which is -2, of course, over 3. Now, having the gradient and of course a point through which this particular perpendicular bisector passes through, we can easily find the equation. So remember, the point through which the perpendicular bisector passes through is the midpoint, which is 5, then of course, comma, 9. Then I'll also pick a general point, xy, so that I can use this particular tool to find the equation of the perpendicular bisector. So of course, this would represent my x1, then this will be y1, then this will be x2, then y2. Now we know that the gradient of the perpendicular bisector should be given by y2 minus y1, then divided by x2 minus x1, or simply put, change in y over change in x. So the gradient of this perpendicular bisector is -2 over 3. So I'll have -2 over 3 being equal to the change in y. Y2 is y minus y1 is +9, then divided by x2 is x minus x1 is +5. If I do cross multiplication, this will multiply with -2, then 3 will multiply with that. So I'm going to end up with the following: -2 into bracket x minus 5, then close the bracket, which must be equal to 3 into y minus 9. On opening the bracket, I'll get -2x. -2 by -5, I'll get +10, being equal to 3y. Then 3 by -9, I'll get -27. So if I take 27 to the left-hand side, I'm gonna have -2x plus 10. Then the 27 will be positive, being equal to 3y. So I'll end up with -2x, 10 plus 27, I'll get positive 37, being equal to 3y. Then of course, I want to express this particular equation in the general form, which is y is equals to mx plus c, but the question did not specify for us to express in that particular form. Therefore, this particular equation can be rewritten as, we can start with 3y, then is equals to negative 2x, then of course plus 37. So this can serve as a solution. Because the question is not specific, but I can also express it in the general form, which is usually y is equals to mx plus c. For me to achieve that, I'll divide through by 3. So I'll have 3y, which is equals to -2x plus 37. I divide through by 3 over 3 over 3. So 3 and 3 will cancel out. So I'll have y is equals to -2 over 3x, then of course plus 37, then of course over 3. So this is the general form, which is y is equals to mx plus c. Therefore, this is the equation of the perpendicular bisector to the line AB. So the key point to note, perpendicular bisector, use M1, M2 to get the gradient. Then the point through which that particular perpendicular bisector will pass through, it will be the midpoint of that particular line whereby the perpendicular bisector is being drawn. Then we move to part C of the question, whereby we are being told that given that AC is a perpendicular bisector to AB and the equation of line BC is this, find the coordinates of the point C. So I'll just sketch so that I see a true picture of what is happening. So I'm having the line AB. I'm being told that the line AB is AC is perpendicular to AB. So perpendicular line simply means that they are going to intersect at an angle of 90. So if this is, we have the point A, which is being shared by AB and AC. So if this is the point C, then of course this is the point B. Of course, the point A is the one here which is being shared. And remember, from part A, I already had the coordinates for point A, which was 3, 6. So A had the coordinates of 3, 6. Then B had the coordinates of, 7, 12. So this is 7, then of course, 12. Then I'm being told that AC is perpendicular to AB. So this angle is 90. Then of course, I'm given the equation for the line BC. Of course, BC, I'll simply connect this particular 2. So this is what we are calling the line BC. We are given its equation to be y is equals to negative 5x, then of course plus 47, plus 47. So for me to find the coordinates for point C, I need to have the equation for the line BC and also AC. So what I'm lacking on AC is the gradient, because I already have the point A where AC is passing through. But because AC is perpendicular to AB and I already have the gradient of AB, remember we got the gradient of AB in part A, which was 3/2. So our M1 is 3/2. We need to find M2, which is the gradient of the line AC. So we know that for any given pair of perpendicular lines, when you take M1 multiplied by M2, the answer is supposed to be -1. Therefore, our M1 is 3/2 multiplied by M2, we are supposed to get -1. So I'll multiply through with the reciprocal, which is 2/3. I also multiply through by 2/3, so that 3 and 3 can cancel out, 2 and 2 can also cancel out. So it means that M2 will be equal to -2/3. So this is the gradient of this particular line AC. It is -2/3. Now, having the gradient at one point, we can easily find the equation. So the point through which AC is passing through is the point 3, then of course, comma 6, which is the point A. I'll also pick a general point XY, so that I can easily find the equation. So this will be my X1, then this will be Y1, then this will be X2, then of course this is Y2. Then the gradient is -2/3. So I want to find the equation for the line AC using these particular points and the gradient that we have just found. So we know that the gradient, which is -2/3, must be equal to change in y over change in x, which is y2 minus y1. So this must give us y2 minus y1, then divided by x2 minus x1. So this will be -2/3, which must be equal to our y2 is y, then minus our y1 is +6, divided by our x2 is x, then minus our x1 is +3. Now, if I do cross multiplication, this will multiply with that. Then, of course, 3 will multiply with the other value. So we're going to end up with -2 into bracket x minus 3 being equal to +3 into y minus 6. So if I open brackets, I'm going to end up with -2x. Then -2 by -3, I'll get a +6 being equal to 3y, then minus 18. So if I take 18 towards the left hand side, I'll end up with -2x plus 6, then plus 18 being equal to 3y. So this is -2x, 6 plus 18, I'll get +24, which is equals to 3y. Therefore, the equation is 3y is equals to -2x, then of course plus 24. If I express it in the general form, I'll divide through by 3, divided by 3, divided by 3, so that y will be equal to -2/3x, then of course plus 24/3, I'll get 8. I can still leave it as 24/3, or I can still write 8. So I have the equation for the line AC, but the question wanted me to find the coordinates of point C. So I'll say that at point C, the equations of the line BC and AC are simultaneous. They are simultaneous. They are simultaneous because these particular equations, this particular line BC and AC are intersecting at point C. You can see this line and this one are intersecting at this point. Therefore, at point C, those particular equations are simultaneous. Therefore, I want to solve them using a substitution method. Therefore, I'll let the given equation, which is y is equals to negative 5x, then plus 47. I'll let this to be my equation Roman 1. Then the second equation is y is equals to negative 2 over 3x, then plus 24 over 3. I'll let this to be my second equation. Now, if I use substitution method, it simply means that where I have y, I'm going to substitute with the second value. So I'll substitute the first equation in the second equation. Since both are equivalent to y, it simply means that I can equate this particular part to this other part, because both of them are equivalent to y. And at point C, the values of y for the line BC and AC are being shared since they are simultaneous. Therefore, at the point C, I'll simply equate these ones because they are both equivalent to y. So I'll talk of negative 5x, then plus 47, which is equal to y, being equal to the other y is equivalent to negative 2 over 3 x, then plus 24 divided by 3. Then to make my work easier, I'll multiply through with the LCM, of course, which is 3. I can let this to be over 1. So I multiply through by 3. So this one by 3, which is the LCM. I also multiply these by 3, which is the LCM. This one by 3. This one also by 3. Of course, the 3s are going to cancel out. So when I cancel out 3, I'm gonna remain with the following. 3 multiplied by negative 5, I'll get negative 15 x. Then, of course, plus 47 multiplied by 3, I'll get 141. 141. Then, of course, this will be equal to 3 and 3 cancelled out. So I'm remaining with the negative 2x, then plus a positive 24. Now, on collecting the like terms together, I'll take 24 towards this other side. I'll take 24 to this side and 15 to the right hand side. So I'm going to end up with 141, then of course minus 24 being equal to negative 2x, then plus 15x. Now, if I take 141 minus 24, I'll get 117 being equal to negative 2x plus 15. I'll get positive 13x. Then I'll divide through by 13. I also divide through by 13. Of course, the value of x will be equal to 117 divided by 13. I'm going to get a positive 9. So that will give me positive 9. Then I also need to find the value of, that is the value of y by substituting through one of the equations. So I'll say substituting. I'll simply say substituting x is equals to 9 in, let me substitute in the first equation. I'm going to have the following. Remember, the first equation was y is equals to negative 5x, then plus 47. So this will be negative 5 into the value of x. We have gotten it to be positive 9, then plus 47. So this will be equal to negative 5 by 9. I'll get negative 45. Then, of course, plus 47. Plus 47. Negative 45 plus 47. I'm going to get a positive 2. I'll get positive 2. Therefore, it means that the coordinates for point C, which should be represented by x, y, will be given by, so C will be, my x is positive 9. Our value of x is positive 9, whereas the value of y is actually positive 2. Therefore, C has the coordinates of 9, then comma 2. Remember, the same equations can also be solved using elimination methods. But for you to achieve that, you start by eliminating the fractions. The answers are going to be the same. So thank you very much for accompanying me until the end of this particular lesson. I do not take it for granted. In case you are new to the channel, kindly hit
the subscription button and also turn on the notification bell so that whenever I upload a new video, you'll get notified. Until next time, this is Kcse Academy. Thank you very much.